I'll also like make this go in.
Yeah, so come tonight if you have trouble setting up. All right, so what is Git? Git is something called a version control system. And what a version control system is basically the practice of tracking and managing things. And that's all Git does. It just tracks changes. So this might sound simple, but it's actually a pretty complicated topic. So let's say we have a coder called Ben, and Ben has one file. And Ben has a friend Alice, and Alice wants to make changes to this file. So Ben sends the file over to Alice. Alice gets the file, makes changes, and sends the file back to Ben. And Ben has the change file, and this is fine, right? If you're working with one file, you can send the file back and forth. It's pretty easy. But what if Ben's working on the code base? Well, there's a lot of code, right? And Alice also has a lot of code. So this is really cluttered, and we can't really make this work by just sending and receiving files and making changes manually. So what can possibly go wrong? Well, the first issue we're going to talk about is with the synchronization of files. So basically, let's say we have Ben and Alice, again, with the same code base, and Ben spots a bug in line 3. But Alice didn't hear from Ben, so Alice just submits the code, and it turns out she submitted a buggy website. And this is not ideal, right? We don't want to submit buggy code. So the first problem that we see is with the synchronization of files. So no one knows which file is most up to date or which file is the ground truth. Another issue is with the collaboration of files. So we have Ben and Alice again, same scenario. And Ben is working on fixing bugs. So he finds a bug in the file. And Alice is working on making the formatting better. So he finds that the formatting is too ugly. So let's say Ben makes changes to the 2 files and Alice makes changes to 1 file. But it turns out that they made changes to the same file. So when they compare code, Ben realizes that their code is different. And Ben has to ask Alice to manually look at both codes and compare and basically just manually merge them together, which is not ideal either. Alice wants that. So we see our second issue here, which is if there's 2 versions of the same file, it's hard to know how to join the files together. And the third issue comes with single versions. So basically, let's say Ben is coding on his own code base now, and he makes some changes to code. So he removes lines, 30 lines from this piece of code, and he adds 24 more lines. But an hour later, he realized he needed those lines. So what can he do? Well, he can't go back because he didn't save at that exact moment that he needed it. So he's done. So now our third issue that we're going to talk about today is that if we break something, we can't go back to a working copy without saving it constantly in the system. So how do you solve this issue? Well, there's a tool called Git. So what does Git do? Basically, Git tracks changes. And how it does this is through map. So let's break that down a bit. So let's say we have a scenario where we're coding on a doc called mydoc.txt. And we have 3 lines of code, and basically I'm writing a story, it's really good, it's bad cats. So there's version 1. And let's say we make a change, we add a line like coordinates to version 2. And then we have version 3 now. And let's say we're making another change, and we delete the line and got cats. So now we have 3 versions up top. And basically what Git does is it tracks changes between these files. So between version 1 and version 2, we have the addition of like coordinates at line 4, and between version 2 and version 3, we have a deletion at line 3. So that's all Git that Git is tracking. So in Git terminology, we call a repository the set of files tracking these files. So basically, this is the code base that you're going to be working on, that all of your teammates are going to send their code to and get their code from. It's basically your website that you're working on. And another terminology is commit. So a commit is basically a package set of changes for a project. Basically, it's the differences between one version of your code to the other, another version of it. Basically, the map between the code, the line between. And finally, the log is a set of commits for each version of the repository. So basically, it's the commit history, the history of all the changes that we have in the repository. So let's go through the problems that we identified before and see if we solved them with it. So it turns out we've already solved the problem of version history. Basically, by keeping a log of all the changes to the file, we can easily revert to any previous version that we need. But what about synchronization and collaboration? How do we solve those issues? We have something called a Git server, or basically a central server that Git hosts that you can push your code to and pull from. Basically, there are 16 members up here, if I'm missing, but basically all the users will communicate with the Git server to make sure that they're most up to date with the code that the team is collaborating. So let's say we have Ben here, this time with only 3 files. And basically what he wants to do is he makes a change to one of the files. He sends a commit to the Git server. Basically, again, a commit is just a set of changes he makes to the file. And this is called a push. So he's making a commit, right? And he's pushing his changes to the Git server. And now the Git server has just changed the code. And now we have Alice with the same code base. And what she's going to do is she's going to pull. She's going to pull from the remote server. And that's going to get all the changes that Ben made and replace her file with the right changes. And now look, we have Ben and Alice having the same synchronized code across their code base. And we have no issues with trying to communicate with each other. So to recap, some of the terms that we've used so far are commit, which is a package set of changes. Basically, again, it's all down to nav, and the line changes, deletions and insertions of lines. Pushing is to send commits to the Git server, and pulling is to get the most updated files from the Git server. So just remember that if you want to push, you're sending files to the server. If you want to pull, you're getting the most updated files from the server. So what about the scenario where 2 people make the same changes or changes to the same file? What if Ben and Alice want to work on the same file? This is called merging. So let's have a scenario again where Ben and Alice have 3 files each, and the server has the same 3 files. Alice makes a change to one of the files. And what Alice is going to do is she's going to commit and push, and the server is going to have all the changes, the most up-to-date changes. So Ben makes changes to the same file. And he's going to also try to push. But what the Git server is going to say is, no, you have to pull this. Basically, the Git server is the ground truth. You can't replace code in the Git server because it's always going to be the most up-to-date code and the ground truth. So what Ben has to do first is he has to pull the code from the Git server. And basically, what pulling is going to do, if you make changes to a file that was already changed on the server, he has to basically manually merge it or automatically merge it. So basically, Git has an algorithm that is able to automatically merge files together if the changes are not conflicting. But in the case that they are conflicting, then we'll have to manually merge them together. And this is a great system because it cuts down on any inefficiencies you have to do by comparing lines of code, but also gives control to the person who's pulling in case they want to make some manual changes. So Ben merges, and once he merges, he can push the file back to the server, commit and push, and Alice can then pull from the server, and all of them will have the same code. So let's go back to our problems, and it turns out we have solved all of our problems that we're looking at today. So for synchronization of files, we can push commits to Git server, and the Git server is always the ground truth. And before you make changes, or before you modify files on your computer, you should always pull from the Git server because it's the ground truth, and you're going to want to make changes to a file that is most up to date. We've also solved the issue of collaboration of files. Basically, we're using an algorithm. It uses an algorithm to merge files into bits. And in the worst case, we can fall back on human intervention if the algorithm fails or there's conflicting line of code. So how do we actually use it? So we actually use something called command line. And this is basically a very quick crash course on command line. Won't be touching upon a lot of commands, but the slides are here for you, and Google's there for you. So some useful terminology that I don't expect you to remember by the end of the semester is a file. Basically, a file is a basic unit of information storage. A directory is just another name for a folder. Any old folder on your computer. Terminal is a command line window. Basically, the place you can write all your commands and communicate with the computer. On Mac, this is called terminal. On Windows, this is called like command prompts. So in the command line, this is useful for later when you're trying to get relative paths to all your files. But basically, the period symbol is for the current directory. 2 period is for the parent directory, and the tilde symbol is for the home directory. This is not that useful for now, but it'll become useful later. So let's do a quick demo of the command line. So as you can see here, I opened my terminal on the Mac. On Windows, again, it's command prompt or whatever terminal you use. And basically, you can see the top line has a name at this random address. And basically, it's saying who am I? It's showing my username at a workstation. Don't really care about the workstation, it's not important. Only care about the user and eventually the app. So we can type in the command pwd, and what pwd is short for is print working directory. Basically, it says our app in the computer, where at. And most terminals also have the current directory. You can see the tilde next to the workstation. Again, tilde represents the home directory, so there's no app right now, but it's just a tilde. So what we can do is we can make a directory. Command line likes to abbreviate a lot of things, so you're going to see a lot of things abbreviated. But mkdir is basically just short for make directory. So let's say we want to make a directory called weblab-command. So once we make the directory, we can do something called cd, which is change directory. So right now we're in the home directory, and we just made a directory in our home directory. So we want to be able to access that. So we can just do cd weblab-command line to go into that directory that we made. And as you can see, our path is updated. Now it's tilde/weblab-command line. And now when we do pwd, the current working directory, we can see that we are in fact, the folder or directory that we just created. And we can just a helpful command that you should know is clear, which is just basically going to clear all the lines in your terminal and have a fresh start. So how do we make files? Directories are obviously not the only thing on the computer. So we can have the command touch, and let's say we want to make a file called index.html. So we can use touch index.html to create a new file called index.html in our current directory. And if we do ls, ls is basically short for list. It's going to list all the files in our current directory. So we do ls in this current directory, we can see that we have one file, which is index.html, which is what we want. And this is just a recap of all commands, but I didn't get to some of the commands because we are short on time. But this is useful, and we should reference it if you ever need it. So let's try using Git. Now we have the tools that we need, the command line tools that we need. We can try using Git on the command line. But first, let's make a repository. Remember, a repository is just a collection of all the code that you're working on your code base. So github.com is going to be the site that you're going to go to a lot during WebLab. Make an account if you haven't already. Basically, we can go to github.com, sign in. Sign in, and you're watching this homepage. For the purposes of this lecture, we're going to make a new repository, but As you might know, the portal automatically makes the repository for you, so you won't have to do this. But in the future, it's nice to know. Basically, what you're going to do is create a new repository. You're going to click new. Here, you're going to just type in a random name for this lecture. I'll say blah blah blah. Test is the name of this repository. Create a repository. And we get brought to this homepage for our repository. And basically, what we want to do is we want to bring this repository, which is remote right now. We want to bring this to our local computer and be able to sync changes between our local computer and the server. So what we want to do is press this code button that GitHub has, and under HTTPS, which is the easiest method, we just copy the link that it provides us. And then when we go to our command line, we can have the command git clone and paste the link to our repository. And basically what this will do is we'll just clone the repository into our own system or our own computer. Remember, when we created the repository on GitHub, that was making a code base that was on the remote server. And we don't have that remote server on the computer right now. So what we want to do is we want to get all the changes or we want to be able to sync our local changes with the remote server. And the way to connect that is to clone the repository. So when we clone the repository, it makes a directory or a folder with that repository name. So we can cd or change directory into that repository. And let's say we want to make a file called index.html, touch index.html. And there's a command called git status. And what git status will do, it will basically tell you all the changes made to a file and what changes that are not synced up with the remote server or the latest changes that we pulled from the remote server. So as you can see here, obviously we made a change to the repository. We added a file called index.html. So we need to commit and push that if we want to update the repository. So how do we push this file to the repository? Well, we do something called git add. So git add file name will add the file to the staging area, which is basically an area in your local computer that holds all the files that are ready for committing. So we do git add index.html. This will add it to the staging area. And then finally, we can do git commit -m and our commit message. So the base command is git commit. And like before, a commit is just a package set of changes. So git commit, and then the -m flag is basically going to say, oh, we want this message in our commit. So git commit -m, the string. Well, the string is just my first commit is the message I want to put out for any collaborators that want to know what we did. So git commit -m message, and if we do git status, you can see that we have nothing to commit because we basically committed all our code. We tracked all our changes already. And another useful command is git log. Remember that we had a log to keep track of all the version history. Well, in Git, this is called git log. So as you can see on the bottom screenshot, git log will tell us all the commits that we made or that our friends have made. And you can see there's enough. And we're not done yet. So this is a step that a lot of people forget. But once you make a commit on your own local computer, you have to do git push to send those changes to the remote server. If you don't do this, you will never push your changes to the server, and your collaborators won't know that you made changes, or they won't get your changes. So we have to do git push to make sure our commits are sent to the server. And once again, we can do git status, and we have nothing to commit. So now if we refresh github.com and go to the repository, you can see we have our first commit. And yeah, basically github.com is going to tell you how many commits there are, which commits from different people, etc. So let's say we're done for the day. We go to sleep. Next day, let's say we want to work on the file that we just created. So remember, we just created a file called index.html, did nothing with it. This By the way, this editor is VS Code. If you don't have it, you can install it at the end of the day. If you don't know how to install it, please join the queue or come to Offsize. Yeah, so we're in VS Code, we have index.html. We add 3 lines of code, basically just a message saying hi. And now, if we do git status again, obviously we've changed our file. And it says that we have to stage and commit some changes. So let's say that we're going to add, in this case, instead of adding one file, what we can do is just do git add dash capital A. And what this is going to do is add all the files, add all the changes that you make, like every single, including additions, deletions, and modifications to files. This is useful if you made changes to a lot of files. Generally, it's nice to just commit or add and commit one file, but people usually use this command to add every file that they made changes to. So git add dash A and git commit dash M, and again the message. And as you can see, we get a little info that we have one file change and 3 insertions. And those are the 3 lines of code that are added to index.html. And let's do git push. But when we do git push this time, you can see it's rejected. And why was it rejected? Well, it turns out Kwon was working on it late at night, and he committed some code, and pushed some code to the world server. And my code conflicts with the code that he put. So to resolve this, we have to do git pull. We have to pull all the changes from the repository, the remote repository. And as you can see, there's a message, there's a merge conflict. So if Git is automatically able to merge them together, there won't be merge conflict. But in this case, it looks like there are direct conflicts between our code. So we're going to have to go through it manually, unfortunately. So if we go back to VS Code, you can see that VS Code has this handy pop-up. Basically, it's going to tell us which is our code and which is the code from the remote repository. The green code is the code that I made, and the blue code is from the repository. A lot of people forget this, so don't worry if you forget what the current change is and the incoming change. You can always Google it. But basically, what you're going to want to do here is compare your code versus the code from the remote repository, and there are 3 options to do it. So right above the green stripe, you can see that there are a few buttons that VS Code provides. You can either accept current change. What that'll do is it'll override the remote changes and just have your changes as the ground. Except incoming change will override your own code that you made, and with the code from the remote repository, which is this code. And except both changes will merge them together. It'll just basically dump all the lines of code that both of you made and like put them together. And in this case, it's not too complicated, so I just chose the 3rd option. And oh yeah, so I commit and must commit. And I chose the 3rd option, and as you can see, both of our lines of code are combined. So now if we go back to the terminal line, the command line, we do git status, and there are some changes we need to commit again. So we git add index.html, and git status just tells us we have to commit some changes, git commit, and git push. And this time we can push without any problems because we resolved all the merge conflicts. Yeah, and if you can get log, you can see the whole history of commits that we made. So the bottommost is the oldest commit. So you can see my first commit was all the way down there. Second commit was when I was sleeping on made a commit. My second commit, which is the 3rd commit in this repository, is when I tried to put text into the index.html, but there's a merge conflict. So finally, merge conflict is counts as a separate commit. So that's the most recent. So if we go to the home page of GitHub, our repository, we can see that the most recent commit is Pittsburgh, which is the commit registry. Okay, so that's a lot. And let me just do a quick recap we learned command line tools and the basics of Git. And these are some Git commands. The left side is what I didn't get to today. This is not too important for the purposes of the web lab because you're not going to make a repository or like push to the local repository to serve. But the right side is all the commands you're going to use in web lab. By the end of web lab, you're going to be proficient and like fluent in these commands. So now it might be complicated, but basically all you have to remember is git add, git commit, git push. And you should always be pulling, because remember the repository is the ground truth. And finally, some info commands are git status together. So to overview Git, the Git lifecycle is git pull. If there are verb conflicts, you have to resolve them, and then add, commit, and push. And you repeat. And git pull is something you should always be doing when you wake up, pull. When you go to sleep, you should pull. Like during the day, you should pull. You should always be pull. And this is a lot, right? So we have two cheat sheets online. Go to weblab.mit.edu/resources and scroll down a bit. You can see there's a command line cheat sheet and also a Git cheat sheet, which will come in handy. Google is also very handy. I use that a lot when I speak web lab. It's just something you have to do by yourself. And before we break for Windows lecture, I want to have everyone basically get the work that we're going to be working with. So if you can all go to weblab.is/catbook and clone the repository, I'll actually do it with you.
Yeah, basically we're going to want to go to weblab.is/catbook, and this will bring us to this repository. Like before, we're going to press code up here. We're going to copy the HTTPS. And then we're going to go to our command line here. And here we're in our home directory, and we're going to do git clone and paste our link. And as you can see, we're cloning Catbook React, which is the repository we're going to be working with during lectures. And if we do ls, there's a bunch of files here, but you can see that we have Catbook React up here. And to go into the repository, we can do cd catbook.react or /react. And we are in this repository, ls again. We can see all the code that we are going to be working with. Yeah, so if you have any questions, again, please join the help queue right on the questions doc. There are a bunch of resources for you. Yeah, does anyone have any questions about what we went over or how to clone? Awesome. Okay. So yeah, so that's the lecture. And next, you're going to learn HTML, CSS with Felina, and then after lunch with Nick and Paul.